Okay, hey, let's see if we can get going on this here. Okay, 7-3, graphing quadratics. You're in this form today, so we're going to add the b in there. Now, as you guys have been working on trying to find your vertex and axis of symmetry, vertex and axis of symmetry, we talked about a formula yesterday. What is the formula for the axis of symmetry? Sam?
Negative b over 2a.
Good. The opposite of b over 2a. That is the formula for the axis of symmetry. All right? It also tells us which value of our vertex? Tells us the x value. So it tells us the axis of symmetry, and it's like a 2-for-1. We get the x value there.
Okay.
Yeah?
So if it's positive, then it's negative, and if it's negative, then it's positive? Or is it always negative?
Yeah, so if b is positive, then it becomes negative when you bring it here. And if it's negative, then it becomes positive over here. You take the opposite.
Okay, that makes sense.
All right? So, if you guys are kind of cranking through some of those problems on today's assignment, let's make sure that we're doing the first few of those, or one or two of those correct. Okay, so number one, find the equation of the axis of symmetry and the coordinates of the vertex of each function. So if I'm going for the axis of symmetry, I'm just going to call that AOS. Okay, axis of symmetry if you're confused. Okay. All right, and in terms of the axis of symmetry, that is the form of x equals opposite of b over 2a. So once you find your axis of symmetry, opposite of b over 2a, and you plug this in, you have to use this x value in your equation to find your y value. It's not just the c value. Yesterday it was always the c value. Okay? But today we've put in the b term. So remember yesterday I said, look, I know this number was our vertex, but I called it our y-intercept. This number, the 4 right here, will always be your y-intercept. However, it's not always this number here. It's not always this value here. You've got to plug in -2 to your equation to figure out your vertex. Okay? So let's try another one real quick. Axis of symmetry right here. Okay, x equals, what's the opposite of b? 6. What's 2a? 2. So we get x equals 3. Okay, there's our axis of symmetry. That tells us our x value. We get to drop that in right there of our vertex. Okay, so we have 3. And then we have to plug that into our equation. So that equals, just going to write it up here, 3 squared minus 6 times 3 plus 7, or 9 minus 18 plus 7. -9 plus 7 is -2.
Wait, so then I have a question. Back to the
What is our purpose for finding the axis of symmetry and the vertex first? Declan? Yeah, so you can start your graph on it. Right? So, like when I move down to 7, let's try to take a look at 7. Tell your neighbor what A, B, and C are. Okay, what's A? B? And C? Okay. Now, if I'm going to graph this, I want to know where to start my table. Right? So that's why I find the axis of symmetry. Axis of symmetry is x equals opposite of b over 2a. Everyone figure out the axis of symmetry? Okay, what do we get? -3, so we get -6 over 2, which is -3. Good. -3 equals x. That equation right there, when I go down to my graph, I can actually go to the x-axis and find -3. That's right there. And this axis, this line, crosses at -3 on the x-axis. That's the axis of symmetry. That's why we have to say x equals -3. Otherwise, could be y equals -3. Then it's going this way. Okay, we've got to say x equals -3. That also tells us the first point of our vertex. That's -3. Which also, in our table of values now, we can bring that -3 down and put it right here in the middle of our table. That's -3. That -3 is huge because it helps us now. We've got the line on our graph. We've got the vertex starting point for the x. And that allows us to build our table. So usually from here, you just count. -3, -2, -1, -4, -5. Now you have the point, your input values for x. And you input those into your equation, your rule. There's our rule. Y equals this. So that's our rule we're using. And notice I'm just going, these are my inputs for x. So everywhere you see x in here, that's going to be an input spot. So I'm going to put parentheses for all those x's. Okay? I'm going to put, oops, I forgot the squared. I'm going to put my 6, 6, 6, and 6, and parentheses, parentheses, parentheses. Dude, very boring. +9, +9, +9. The only thing that is changing is the x. Then you plug things in. In fact, I'm going to find the vertex first. I'm going to put in that -3. -3 quantity squared is, that's 9. Now, I see some students when they build the table, they leave a little room up above it so they can rewrite the answer. They put like, there's 9 right there. And 9 plus, well, 6 times -3 is -18. So I have 9 minus 18 plus 9. 9 minus 18 plus 9 is? 0. It's not going to always be that number 0, by the way, but it just happens to be there.
Wait,
It's -3, 0.
wait, why would it do that? Negative, is that -9, the first number?
-3 squared, it's -3 times -3?
9.
Positive 9.
Minus 8 is 1.
9 minus 18.
Oh, that's, oh, okay, now I get it.
Danny?
When you're graphing, do you want us to graph vertex or the axis symmetry? So just
You put them both on there. So there's the axis of symmetry at x equals -3.
And then you want us, like, if it was different, like, say it wasn't 3, 0, so they weren't the same, you want us to graph both of them?
Well, they will be the same. The x and the axis of symmetry will always be the same. So like
But you
the,
said it's not.
the vertex is always going to lie on this line somewhere. But it won't always end up like right there on the x-axis.
Yeah, but, like, if you're just finding the axis of symmetry, you're just finding x. So, say it was, like, -3, 4 was the vertex, would you want us to graph -3, 0 for x and then -3, 4 for the vertex?
No,
You just want -3, 4.
correct.
Okay.
Yeah. All right, so let's plug in all these other values. Finish up our table. Put in our -2 or -1. Put in your -4. Put in your -5. Finish up your table there.
Top 2 or the bottom 2? Do we need to do the other?
Maybe just as a check, so like if you calculate this one, you end up with 4 minus 12 plus 9. And so what is that?
1.
1. Okay. So that should be the same as this, right? You can always check it. It's always a good thing to check. What's this give you right here? 4. 4. So it was right, Rylan, right? It should show your work, right? Rather than just throwing them into the calc. Okay. Okay, we got -2, 1. And that's the reflection. We got -1. Oops, 4, not 5. That's the reflection. Now, like I said, there is a shortcut where you would be able to find these other points without having to create a table. But I'm going to let you try to figure out that pattern. I'm not going to give that pattern. And you're not going to tell me that pattern.
No, I'm not.
Oh, okay, yeah.
But, so if we find it and then we don't fill out our tables in our homework,
Well, you've got to at least fill out your x and y's. I don't need to see
Yeah.
the stuff in the
Oh,
middle.
okay, okay.
But those of you that are struggling with this, you should be showing your work here. So don't call me over and say, I don't get it. And I go, well, I don't see what you did. Well, I did this. Okay, I want to see what you did, not, I don't want you telling me what you did. Okay? You got to show that so that it can help you. All right. Any questions? Okay, quiz tomorrow, 7-1 to 7-3. Let's be ready for it. Okay, answers are on the board. Let me know if I can help.